Good afternoon, everyone. It is very motivating for me, very encouraging for me, very heartening to see that 24 of you are there for the class even before the class could start. You are before time. Keep it up. If that's the level that you maintain, I can assure you, you will do very well in physics. So let me honor you by taking your names. How come from 24 the number all of a sudden dropped to 18, 19 when the class started? Visa Lakshi Chillar, Deepak Rajput, Parth Sharma, Pratham Gupta, Navnoor Kaur, Pallavi Thapar, Mudit, Parth Sharma, Pratyusha Kumar, Visa Lakshi Chillar, Shivangi Shah, Aniket Chattopadhyay, uh, Mudit Adrian, Dev Roy, Atul Verma, Swastik Barnwal, Rishika, मीता पी कुमार, रितेश वाधवानी, सना, कशिका, अर्जुन गोगिया, उद्भव यादव, अक्षत बहल, अश्मिता बनर्जी, आदित्य मृदुल, अंश भाटिया, शिवेन अग्रवाल, ख्वाहिश जायसवाल. Welcome, good afternoon. And now we are 37, 38. 38 people are there, right on time, and that's a great gesture. My blessings to you. Keep it up. Today's class is on calculating. Calculating. I have been telling you that we won't have Kevin Jacob, Abby Abraham, Pratham Gupta, Kriti Rao. All welcome. Khwaish, welcome. So I have been saying that I will not be using much math. We will be talking more physics. But I have also been telling you that math is the language of physics. But then wherever we need math, I have been telling you how much math you need and why you need, and what would be the benefit if you do that much of math. I have been sharing it with you. So, in that series, today we are going to calculate how much is normal reaction. Now, we saw that why or where did this normal reaction come from. We saw in that example of car moving on the road that the car on the road was not going down even though the gravity was pulling it down. Aryan Art, Ritvik Bhatia, good afternoon. But now I will not be responding to your good afternoons. Hai na? So all those who were on time, I have responded to you. So we saw that car which was going on the road was not going down even though gravity is pulling it down. And you people could reason it out that the road is exerting an upward force which is balancing that gravitational force. So let me start the day with that activity that we were doing. This is your surface, the road, and this is that car, and it goes on the road. It doesn't go down because you say, let me choose a surface which is easily visible. Yeah, now it is easily visible. Yeah, color choices have to be good. Now the question was the force with which gravity is pulling it down and the force which this book is applying up, which one is more? So to make the thing clear, what I did, I took it in my hand. Now, is this body going up? No. Is this body going down? No. So, is there a net force in the vertical direction? The answer is no. So, it means downward force and upward force must be equal. In physics, we say body at rest has remained at rest. This body at rest has remained at rest. It means the net force acting on this body is zero. So the downward force, which is the weight of this block, and the force that my hand is applying up, they should be equal. They should be equal. But there was a question raised that when my hand is not moving up, how can it exert an upward force? Well, my observation is this, that if my hand is not there, and then you try to keep this thing here, it goes down. It means my hand was applying an upward force. And because this body did not move, so the force that my hand applied upward should be equal to the force applied by gravity on this body, which is the weight. So I take that question which was put up, the force exerted by my hand on this block, that if my hand is applying force more than the force due to gravity. Let me clarify. Right now, my hand is applying a force up and the weight is acting down. If my hand applies a force more than the weight, so the situation will be like this. Let me use some kind of drawings which will help you in visualizing. So I have a block and my hand is applying a force upward and I'm calling it F1. And there is a force which is acting downward, which is called its weight. I can call it as mg also. This F1 we have already seen is called the normal force, or it is called normal reaction, and we will see how much it is. Today is the class that we will see how much it is. Now this I am calling as F2, this weight. If F1 is equal to F2, then what you saw will happen. Body at rest remains at rest. Okay, so now guess, if F1 is greater than F2, is if the force that I apply is more than the weight, what do you expect will happen? Station, I think I should number my questions, because because of delay, people are answering to this question, whereas I have already moved to this question. So, see, yes. So what I am doing is I am naming these questions something. So this is 1 and this is 2. And now when you answer in the comment, when you comment, write 2 dot first and then you write the answer. That way there would be no confusion, no communication gap between you and me. Very good, very good, very good. And you are able to visualize it easily. You are able to visualize it, है ना? You can visualize it that if F1 is more than F2, then this body will move up, है ना? My only question is, let's pull you ahead of this. Will it go up? You are saying moves up. This is what you are saying, most of you, and you are saying it correctly that it moves up. My question to you is, does it move up with constant speed? With constant speed or varying speed? What do you guess? And now write 3. This is a convention that we are setting up so that there are no communication gap between you and me. When you write your answers in the comment box, in the chat box, write 3 first and then say something. Akshat Bahal says varying speed. No, it depends. So I need to ignite your thinking, है ना? 3 varying speed. See, that's it. Now 3 constant, varying speed. Adrian, listen to what I'm saying. Write 3 first and then write answer. No, it accelerates. Okay. Varying. Okay. Let me give you a way to think about it. Yes. Uh, no, that's a very politically correct language. That uh, politically correct language, Mudit. If there is no acceleration, then movement will be constant. You have to tell me, if is there an acceleration? If there is an acceleration, the speed keeps on changing. If there is no acceleration, the speed remains same. Yeah, that is always correct. What will happen in this case when F1 is more than F2? Do you get acceleration? So does the speed changes? That's what the question is, Mudit. It goes up with a constant speed in ideal situation when there is no drag. Anshul, there will be no drag. Till the time it is mentioned, there will be no drag. And we are very good. We physics people are very good in making all these kind of assumptions. So no air drag. Air does not even exist. You will find even in projectile motion, etc., when we throw a ball, air does not even exist. That's actually level up kind of physics where you consider air drag, all those kind of things. The maximum these things that we consider is friction, and that is a constant kind of friction. So you will see things are not that much tough in physics. We simplify this world a lot, and then we develop our models to understand this world. Okay, so now let me give you my hint for you to think. This body was at rest. This body was at rest. And now you apply an F1 which is more than F2. So there is a net force. Yes or no? There is a net force. Let me continue with this color. In this case, F1 minus F2 is the net force. And what you do is what Newton taught so many years back. This net force, you put it equal to ma. So your acceleration A is equal to net force upon the mass of this body. This is the acceleration. So whenever you have a net force, I'm not saying force, whenever you have a net force, you will always have acceleration. And now you see that your answers will start coming very sensible. Everybody will be giving correct answer now. Now tell me, will it move up with a varying speed or with a constant speed? Write three first. Write three first. Three and then write your answer. Whenever you have a net force, like say F1 is more than F2, there is a net force, you will always have acceleration, which is equal to, from F equal to ma, F by m. Now you tell me, will this body move up with a varying speed or constant speed? Write 3 first. See? Now you look at the chat box and now varying with acceleration. Deepak Rajput, any reason that you are saying constant? Adrian, there is a net force. F1 is more than F2. That we have already decided. You see here on the screen, F1 is more than F2. This we have already decided. F1 is more than F2. So now I see, except for say one or two people, and gradually they will also start concentrating on what we are talking about. Now all answers are coming out to be are in unison. Varying. Now do you understand? Because there is an acceleration. Whenever there is a net force, now you should not say it depends whether there is a net force. I am telling you now that there is a net force because we have decided F1 is greater than F2. In that case, this F1 minus F2 is the net force. Okay. And so if this net force is divided by mass, then you get acceleration. And because you have an acceleration, the speed will keep on increasing. If any other thing confuses you, that must be like, what about air drag? There is no air drag. I told you the physics you are going to study is actually very simple. You will see never you are troubled with those kind of things, that there might be an air drag also and all those kind. I could see that your comment actually got posted earlier. I understand that. So now I see one thing, that you people have understood the basic thing. that what it means if there is no net force, what it means that F1 will be equal to F2. We are going to utilize this thing, this knowledge, to calculate this knowledge that if neither speed has changed nor direction has changed, then or say body at rest remains at rest, then even if there are forces acting on the body, their net is zero. We are going to utilize this knowledge to calculate how much is that normal reaction. Okay, so that's today's class. This we have done. Now before we calculate the value, a little description, say from my side, about the direction of this normal reaction and why it is called normal. The opposite of this normal reaction is not abnormal reaction. Normal reaction, abnormal reaction, no. This normal is actually, it stands for the perpendicular. Normal, no, drop a normal, the normal to that surface, yeah. So this normal that we are talking is perpendicular. I really don't know who taught English to these physics people. I really don't know. Sir, in this question, is the net force constant or not? Yes, in this case, F1, let me go back to that screen. In this case, whatever is F1 fixed, and whatever is F2 fixed. Yes, if this F1 is varying, then in the question it will be written very, very clearly. Vijalakshi, have I answered your question? So whatever is F1 is fixed F1, whatever is F2 is fixed F2. So F1 minus F2 is also fixed. So net force is fixed, and so divided by mass, acceleration is also fixed. I'm telling you, I'm not simplifying things for you. I'm honestly telling you that the physics that you are going to do is not that complicated kind of physics. It is actually made very simple. So all these questions that you are having, they are good questions, they are genuine questions, but I can assure you that all these things will go into assumptions. And we teach one thing. When we will be coming to those strings also, that when bodies are connected to the string, then and that string, the nature of the string plays a role. And when that string goes over a pulley, that pulley, nature of the pulley plays a role. And so in physics, there is a, big formality, we say, like the way they say in Mughlon ke darbar mein, when they used to go to the king, they would do some kind of thing 3 times, they will bow down to him. So that used to be custom. Likewise, you will find in physics, there is a custom to describe things like the string is massless and inextensible, the pulley is frictionless and massless. All that thing is part of making the situation simple, removing all these complexities that air might be blowing, wind might be opposing the movement, all those kind of things. There might be something troubling the movement, something not allowing the body to move freely. All these kind of things are taken care of. Okay, so honestly, I'm telling you that the physics that you are going to do is not that kind of complicated. If you keep your common sense intact, which right now you have in abundance, I am telling you, take my word, I have been teaching physics for 22 years. You will do very well in physics. Physics will not appear difficult to you. So now coming back to this, just a second. Where have we gone? Okay. So were talking about, first thing I said, before we calculate, we will learn about the direction of normal reaction. That what is the direction? And I said this normal word, if we are simplifying, how do we apply it in real life? Yeah, gradually you increase that complexity. Aniket, so the physics that you handle at the level of engineering, that has everything. But then to understand the concept, you need to study that concept in isolation. So many simulations, and the reason I like simulation, there are many physics people who don't like simulations. They say this is not physics. This is ideal kind of situation. I say, but then these simulations allow you to study one parameter, one variation, one factor at a time. And it helps you to understand. Once you have understood those in simplicity, one at a time, then even if they are combined together, you will be able to handle them because you have learned it right. Okay. We will continue with those kind of discussions. So first thing that we are learning is the direction of normal reaction. Direction. What is the direction? Rule number one. Listen, we are going to study rule number one, rule number two, rule number three. And here it is not one of the rule will apply. No, it is in sequence. First, you will see rule number one, and you will see most of the time it is rule number one which is applied. Very rarely goes to rule number two, very, very rarely goes to rule number three, but then most of the time it is rule number one. You go to rule number two only when rule number one fails. So I will just quickly mention rule number two and rule number three. I won't spend much time on it, but because rule number one is something you are going to apply most of the time. So let's talk about it. What is the direction of normal reaction? Rule number one is very, very simple. It says it is normal to the surface on which the body is kept. So this body is kept on a flat table, है ना? This is a horizontal table. This is a horizontal table on which a block is kept. So the table surface is like this, perpendicular to that table surface, the surface of the table perpendicular to that. Now suppose this body is kept on a slope like this. See, it is sliding. That is okay. It is sliding. That is okay. It is going down the slope, but it is not moving like this. See here, the surface is like this. The body is not moving. Okay, what I'll do is I'll take a rough surface so that there is no confusion. Little rough surface. And I will take the... Just give me a second. Okay. Yeah. Now it will work fine. This is the case I'm talking about. A body is kept on a slope. The direction, we will see the magnitude also, the direction. Normal to the surface. Normal to the surface. See, right now this is the surface, normal to the surface. Right now this is the surface tilted, normal to the surface. So rule number one says, whatever is the surface, perpendicular to that surface. Now comes the third case, the third diagram, in which this, say like a duster in your class, I am holding this eraser and there is a surface and I am pressing it against, like you press it against the wall or against the blackboard, you are pressing your duster. This surface is applying a, see, try to, let's discuss it the way we were discussing it earlier. Is this eraser going to your right? Is this eraser going to your left? If it is neither going to the left nor to the right, then I am applying a force towards my right. This is, I hope you are able to, this is visible, or let me put it like this. Now it is more visible to you. Now listen, but then there will be no right and left. My force, the finger, the force that it is applying is in this direction, I'll draw it on the screen. But even though my finger is pressing it, it is going nowhere. It means there is some force acting on this eraser which is equal and opposite to the force that my finger is applying on it. Let me repeat because this is important. My finger is pressing this eraser, but this eraser is going nowhere. Pratham Gupta has written something. Sir, is there any relation between normal force and third law of motion? Pratham, there is. There is, but then third law has to be understood. This equal and opposite has to be understood. What I am talking about is an application of third law, but I will come to it. I'll come to it. Right now, concentrate on this part. This is an eraser which is pressed against the, say, this notebook or whatever. It could have been in the duster and you press it against your blackboard. Okay. My finger is applying some force on this eraser. Let's say that force is P. We will come to that, but then you start understanding it better. So there is a this is that notebook, and this is that eraser, and your finger is applying. My finger is applying a force. Let's call it P1. But then the eraser is going nowhere. It remains there. Body at rest remains at rest. Harpreet Singh, sir, if your finger does not possess any force, then why does the duster not go to the right, rather gravity acts on it? Gravity wala part also we'll talk. Harpreet, that's a good question. Actually, a good question. I'll talk. You mean to say why, if my finger is applying to the right, why doesn't it go down? Huh? Yeah. First, let's talk about the horizontal case. So my finger is pushing this eraser, but this eraser is not going anywhere. Right or left, it is not going horizontally anywhere. It means this notebook or this surface is certainly applying a force like this. Something, this surface is applying a force like this. Do you see this one? This kind. And you can even, if you have understood, you can even guess its magnitude. That how much is the magnitude of it, you can even guess that. Is it more than P1? Is it less than P1? Is it equal to P1? You can have a good guess. Point to consider, me lord, is that when my finger pressed this eraser, the eraser went nowhere. Eraser did not move. Did not move. Good. Nice. Very good. So it means you have even been able to calculate the value, that how much is this, and you have been able to calculate the value that it is equal to. Very good. Excellent. I was getting a feel that I am not able to explain it properly because nobody was writing, but then seeing your answer, sir, I am trying to say, if suppose the finger does not possess any force, normal is acting then also. Okay. What you are saying is, if my finger is not pushing it, is the normal still getting applied? Is the normal still getting applied? Ah, okay. I thought that you are saying that you are applying horizontal force. Normal force is also horizontal. Why doesn't it go down? I initially thought that. I'm sorry, I understood your earlier question wrong. What you are saying is, if your finger is not applying, then is this force still applying? Is this surface still applying something? You try to do this activity yourself. What I will do is, I will remove my finger now, so that you can see what happens if I remove my finger. Because it needs a little bit more understanding, and with that you will understand when it comes to friction, that how much is it, that you will understand at that time. But right now what I'll do is, I'll show you what happens. If my finger is not pushing it, this is what happens. So you will say, how does it prove whether it is applying any force or not? Yeah, little bit more when we come to friction, we will see that what was holding it so far. When I was pressing it horizontally, what was holding it from falling down? When you start understanding that, then you will be able to appreciate this also, that if I remove my finger, is this surface still applying force or not? Now this time I think I have understood your question. Have I answered your question? Okay, so this is rule number 1, and because rule number 2 and rule number 3 you won't be applying too much, so I will come to the value wala part, the magnitude wala part. Already you have done one question, but let me leave this rule number 2 for some other later day. Rule number 2, rule number 3, and come to this part, which is the magnitude part. Now, this one you answered it earlier. This one you answered me earlier. N and mg, that if body at rest remains at rest. Okay? Means this you have to say. Otherwise, things will change. So I have to say this thing, that this body at rest remains at rest. There is a easier way to say all these things. You know what we say? A block is kept on the table. Now you see it means the same. Both these languages, they mean the same. This language and this language means the same. The first language is too much explicit, very clearly says that, but second language is the common language that we use in physics, but both these they mean the same. A block is kept on the table. That's it. Kept means rakha hai na? So neither it is running away nor it is going down, going up, nothing like that. Now this one will need little bit more of your math. And let me see if I'm able to explain to you how to find this one. So there is little bit that you will have to understand regarding this. And then you see why you need this much of maths. Let's say there is this slope has an angle theta. Means this angle is theta. And here, somewhere here, there is a body kept whose weight mg will certainly act towards the center of the earth. Mg will act this side. Now let me complete few more things in it. If this is theta, this is 90. In my opinion, you can understand this. Okay. So in case you are not able to understand, do let me know if I am not able to explain it to you. Because this is a little bit of mathematics. So if this is theta, this is 90. This thing will be 90 minus theta. Okay. Now this is 90. This is a normal that I'm perpendicular that I'm making. So this angle has to be theta. Fine. What I want is, now this is where those knowledge of vectors would have come handy. What I want to do is, let me take you back and explain this thing in a separate piece of paper. Okay, trying to explain this thing to you, and this might sound little bit heavier. But what you know already, let me check that part and remind you of that part. Say in a diagram, in a triangle, this is say theta. This is say, I don't want to use that x, y, r, or might be it's okay. X, y, and let's say r. So x upon r is your cos theta. Y upon r is your sin theta. This is basic mathematics. I hope that these are not, these doesn't sound too mathematical to you. How much is x? This x is how much? R into cos theta. This side is this much, okay? How much is y? R into sin theta. Now you come to that case that we were doing earlier. Theta. This is your mg, weight acting down. We must draw vectors mg cos theta and mg sin theta. Yes, Mudit, yes. And if you can handle it, I can straightway give you the conclusion. But then if you, in case you find it a little difficult, I can explain it to you also. So this is 90. This is 90 minus theta. And this is theta. Now, if you want to see this effect of mg, how much is in this direction and how much is in this direction, this is called resolution of vectors. Now, we haven't done vectors. And I said that wherever we need it, we will handle it there. Okay. I'm giving you the conclusion first because you will be needing it again and again. Whichever side you know theta, that side will be cos always. And which the other side will be sine. So this will be mg sin theta. let me repeat this thing for you so that you will be able to remember it even better. Let's say this is some vector r and this is theta. Then if I say how much it is in this direction, so either you can try out these kind of things, that this is r, how much is this, you can calculate it using these kind of diagrams. Otherwise, remember the result. Whichever side you have theta, this thing will be r cos theta always, and this part will be r sin theta. Now let me take another example so that you can, it starts fitting into your mind. Let's say this is theta, then this part will be r cos theta. Whichever side you have theta, that will be cos theta, and this side will be r sin theta. I hope that now you will be able to at least correlate. Now if you want to see how did it become r cos theta, you can use this kind of thing, that say this side upon this side is cos theta, so how much is this side? You can use this kind of relationship. So I'm going back to what we were doing earlier, this part, and here what I'm saying is, just a second, that this was our mg, this is mg cos theta, and this is our mg sin theta. Now back to this example. This block kept on a slope, normal reaction mg cos theta. Very good, very good, very nice. Okay, so this block, if you keep it on the slope, it might be coming down the way it is coming down here, or it might not be coming down the way it is not coming down now. It might be coming down, it might not be coming down, but then this part, it is not moving here or here. Means this normal reaction perpendicular to this surface and mg cos theta, these two, they seem to balance out each other. And so what one of you has answered, n in this case is mg cos theta. In this case, n was equal to mg. There is one more case that you have already done, and that part was this wala part, that if I am applying a force P1, then this surface is also applying a force N, this surface, and this N is equal to P1. This you already understood. Will it move with acceleration g sin theta? Aman Verma, you have understood it right. See, mg cos theta and n are balancing out each other. So n is mg cos theta, but then who is balancing mg sin theta? No one. So downside, it has a force mg sin theta, and if you divide by m, it has an acceleration of g sin theta. Certainly, Aman Verma, very good. Okay, so we have seen three cases. We will continue. There are few more cases in which we have to learn normal reaction. These are not very tough, but then for today, these are the three cases that we have learned how to find normal reaction. There was one additional information that you required, and the knowledge of vectors, but that was quite basic, quite basic. And there also I gave you a way to remember it, that if you have to find something like this, then whichever side you know the theta, that side will be always be cos. We will someday have a small class on vectors so that all these things are formally learned. Vectors, and we don't need much vectors. I'm telling you, we don't need much vectors. Whatever we are doing, that should be good enough kind. We should be able to manage and learn our physics without much vectors. But then a small short class on vectors we will do someday, which can cover up these things. Your next class is on Thursday. TTS will be your classes, Tuesday, Thursday, Saturday at 2 o'clock. And in the next class, kindly see the recording of it, see it again. If you have understood these three cases, then in the next class, these are the cases that we are going to solve. Normal reaction in these cases when there is an additional force acting on a block, This one we have done, the right one. The right one we have done. This case, lift, free fall, etc. These cases more. Few more cases that we are going to do. So next class, if you have understood today's class and if you are willing to see the recording and put some effort, in next class you will be able to find normal reaction in most of the cases, and one of the topic you would have done thoroughly. Sir, in the second, mg sine theta object is stationary, is that y n equal to mg cos? Yeah. uh, you are talking about this case. The second case you mean, Pratyusha, is the second wala, the down wala case. Because this block is not moving perpendicular or in going into the slope, it is going along the slope. Yeah, so that is mg sine theta which is causing that. Along this direction, there is no movement. Neither it flies up nor it sinks into the surface. So these n and mg cos theta must be equal with the same logic that was in case 1 as the same in case 3. So Pratyusha, that part you have understood it correct. Because it is stationary, perpendicular to the slope, it is stationary. It moves along the slope, but perpendicular to the slope, it is not moving. So it means n and mg cos theta must be equal. I think, have I explained, have I answered your question, Pratyusha? Okay. Mudit, moving or not, forces of y axis cancel each other. Now, which one is your y? Mudit, if perpendicular to the slope is your y, if perpendicular to the slope is your y-axis, then yes, what you are saying is correct. Whether it moves along the slope or doesn't move, along y, your n and mg cos theta are equal, whether it moves along the slope or not. Yes, Mudit, that way you are correct. Okay, good. The class became little slightly mathematical, but I hope you will manage this much. Tuesday, today is Tuesday. Now, next class is on Thursday, 2 o'clock. If you go through this recording and understand this much, then Thursday you will be easily be handling normal reaction, its direction and its magnitude. I have also posted in the Telegram group, I have, and on my Facebook and on other social media that I have posted about a course that HC Verma sir is starting on 2nd April about doing experiments activities in physics. My strong recommendation that you join that course. It's free. HC Verma sir's all courses from HC Verma sir are free. He never charges anything. The way this course that you are doing on YouTube, this is free. His courses are always free. So I strongly recommend, because you will enjoy doing physics with him. See you on Thursday, 2 o'clock. And I hope that you will spend some time to understand what we have done so far. Thank you, and see you again on Thursday at 2 o'clock.